Okay, let's take a look at problem 2 of problem sheet 7. So here we have an SR latch, and this is a edge triggered a latch. As you can see, the triangle here, and you can also see the bubble. So it's a negative edge triggered latch, right? So which means that the all the action in the SR flip flop is going to happen at the negative edges, which are these edges, right? Okay, so the action is going to happen at the negative edge, but how does an SR flip flop work? What is the truth table? So if you remember, uh, SR, and you could write Qn plus 1, right, or Q plus. So if S and R are 0 and 0, we have the same state being maintained. If S is 0 and R is 1, we have the reset condition, which means that Qn plus 1 is going to be 0. If S is 1 and R is 0, then we have the set condition, and we do not allow 1 1. 1 1 is usually not allowed in, it's an invalid state in the SR latch. Okay, so that's how the SR latch looks. So let's use this truth table to now figure out what the values of Q and Q bar are going to be. So we'll just do Q, and Q bar is just going to be the opposite of that, right? So let's take a look at this point here. So at this point, what are the values of S and R? So S is 1, R is 0, and so 1 0, which means that we are at this state, right? We are at the in the set state. So Q becomes equal to 1 at this point. So let's assume that it was 0 before and it has become 1 here. Okay. Um, Give me a moment. Okay. Now what happens at this stage? At this stage again, S is 1, R is 0, so we remain at 1, right? The output remains at 1. And then what happens at this state? This state we have S equal to 0 and R equal to 1. So we have the reset state. So we will have 1 till here, and at this point your signal becomes 0. What happens at this state? Now you have the set state again, 1 0. So the output is going to go higher to a high, okay? And then at this point, again, S is 1, R is 0, so we continue to be in the set state till this point. And here we have S is 0, R is 1, so we are going to the reset state, so you are reset. So Q becomes 0. And then here we have again S being equal to 1 and R being equal to 0. And then S and R are not changing, so it just remains like that. So that's your Q, and Q bar is just going to be the opposite of that, isn't it? You can draw the transition times, there you go, and then you can just say opposite of that. So 0 here, here Q is 0, so Q bar is going to be 1, and then Q is 1, so Q bar is going to be 0, and then we Q bar again becomes 1, and then it becomes 0. So that's your output.